Hi, this is Video Explainer for week 3, and I'm going to be solving this problem from the Mastering Physics homework. A 3-meter long ladder, as shown in Figure 1, leans against a frictionless wall. The coefficient of static friction between the ladder and the floor is 0.46. And the question is asking, what is the minimum angle the ladder can make with the floor without slipping? Express your answer in degrees. So what I first did was I drew out this figure to represent what's going on in the situation. So it says that the ladder is leaning against the wall. The ladder has a length L of 3 meters, and it creates an angle with the floor, which is going to be described as theta. And so we're going to be solving for the minimum angle the ladder can make with the floor without slipping. So first, we're going to define the forces that are involved in this interaction. First, the forces in the x direction, we can assume that's going to be the force of friction and also the force of the wall on the ladder. So we can assume those are equal. And so since they are equal, when we subtract force of the wall, subtract it from the force of friction, we're going to get 0. And since the force of friction, we can define that as the coefficient of static friction times mass times gravity. And in this situation, the coefficient of static friction is 0.46. And so the forces in the y direction, it's going to be the normal force, which is equal to mg. And so we can assume that the normal force minus mg is also going to be 0, since they are equal to each other in this situation. So the forces in the x direction must equal the forces in the y direction in order to balance the ladder at a minimum angle without slipping. So for that case, we're going to have to write a solution where the forces are balanced, and then we can solve for the angle. So the forces in the y direction are going to be 1/2 the length times mg times the cosine of theta, and then the forces in the x direction are going to be the length times the force of the wall times sine of theta. So if we equal those together, we get this equation, and then the force of the wall is also equal to the force of friction, and we can assume that the force of friction is equal to the coefficient of static friction times mass times gravity, and so we can write it out like this. And since there are 3 variables on each side of the equation that are equal to each other, we can cancel those out. And so we get this, which is 1/2 times the cosine of theta equals the coefficient of static friction times sine of theta. And after some rearranging and also some trig identities where we can assume that the sine of theta divided by the cosine of theta is equal to tangent of theta, we can take the inverse tangent of 1/2 divided by 0.46 to get the minimum angle. And so the calculated minimum angle is about 47.39 degrees. And this is the minimum angle that the ladder has to make with the floor without slipping. So I think that the primary concepts that are involved in this problem is the conservation of momentum, the law of conservation of momentum. And this states that the forces involved in an isolated system must be equal to each other in order to conserve momentum and to play out these types of situations. And I think the tricky part of these problems is to figure out where every variable goes and how to make the net forces in the x and the y direction equal to each other, and also to figure out which particular forces are relevant for the x direction versus the y direction. Thank you.